Alright, so I'm solving a physics problem about atomic and nuclear. It is 2012 AP Physics, the response section. Don't know if you can read that. It's worth 10 points. It says the momentum of a particular proton is 5.5 times 10 to the negative 20th kilogram meters per second. Relativistic effects can be ignored throughout this question. I wish I knew what that meant. A. Calculate the de Broglie wavelength of the proton. And I started to film the video before and it randomly cut off. And basically what I was saying is I had down formula wavelength equals h over p, Planck's constant over the momentum. So I plugged that in, and if I type that into my calculator, 6.63 times 10 to the negative 34th divided by 5.5 times 10 to the negative 20th. I get, give me a second. Great Gatsby soundtrack is fantastic, by the way. Okay, I get 1.2054555 times 10 to the negative 14th. So 1.21. I'll say 205. I think that's, no, just kidding. I'm only supposed to have 3 sig figs. So 1.21 times 10 to the negative 14th. Yep. So you get that. Now B says calculate the kinetic energy of that proton. So in order to, what the heck is going on? Oh, there we go. Okay, so B says calculate the kinetic energy of that proton. So I know that K equals 1/2 mv squared, obviously, and I'm given the momentum, and I know that P equals mv, so I can plug in I'm going to move this down to the bottom. I can plug in 5.5 times 10 to the negative 20th equals the mass of a proton times its speed. So I get that the speed is 5.5 times 10 to the negative 20th over mass of a proton, my handy dandy green sheet, equals 1.67 times 10 to the negative 27th kilograms, obviously. Plug that into my calculator. 5.5 times to the negative 20th over 1.67 e negative 27th. And that gives me a speed, that is a big speed, but it gives me a speed of, I'm going to put this into times 10 to the, so it's, 3.33 times 10 to the 8th. No. 1, 2, 3, 4, 5, 6, 7th, sorry. 10 to the 7th meters per second. So now I have my speed, and so I have K equals 1/2 mv squared. So I can just plug that in. I found, I'm finding kinetic energy. Later I'm gonna use that, but so 1/2 times mass of a proton, which is 1.67 times 10 to the negative 27th, times the speed 3.3 e7 squared. This is just making my night. This gives me a whopping answer of, let's hope it sounds right, 9.09 times 10 to the negative 13th joules. Alright, so that would be, woo. Now C gives a new little paragraph. It says the proton is directed toward a very distant stationary uranium nucleus, U-235-92. I don't know how you say it. 235 is on the top left, 92 is on the bottom left. Then it says the proton reaches a distance d from the center of the nucleus and then reverses direction. Assume that the nucleus is heavy enough to remain stationary during the interaction. I'm going to treat this as a conservation of energy because, yeah, it's far away, comes close, reverse direction. So K original plus U original equals K final plus U final. And because it reverses, it says assuming the nucleus is heavy enough to remain stationary during the interaction, because it's moving, the original K, like when it's, is going to equal, because the original potential energy is 0, and then the final kinetic energy is 0, because it says it remains stationary during this thing. So we know that KO, or K whatever naught, K naught, I think that's the one, is equal to U final. So we know K naught equals U final, and we know from the charges thing, where's my green sheet? We know from the charges thing that U is equal to, where'd that go? K Q1 Q2 over R. So by obvious reasons, hang on. KO, the original kinetic energy, is equal to K Q1 Q2 over R, because that's what U equals. Why does this thing keep popping up on my computer? Sorry. So now we know that the R is just D, and Q1 Q2, we know that the magnitude of it is 92 because of what it gave us earlier. So we have K naught equals K, the constant, times the first charge is 92, times the E, electron, and then you have the second one, which is just going to be E. That's the Q1, Q2, and then over D, because it says it reaches that particular distance. Yeah. So we have that first charge of that uranium thing, and then we have the electron charge magnitude. So with that set up, we can basically easily solve for D, which is just 92 E times K over KO, which is the K that we found in the previous problem. 9.09 times 10 to the 13th. So that's easy to solve for. 92 times E, which is, where'd it go? Why do I keep losing things? Which is 1.6 times 10 to the negative 19th. So 1.6 times 10 to the negative 19th. Sorry. And then K is equal to, then again, because you have 92E times E, so 1.6 times 10 to, I guess I could have squared that. Oh well. And then times K, which, where did that go? There it is. Coulomb's law constant, 9.0 times 10 to the 9. Plug that bad boy in. And then all over K, which is what we found, 9.09 times 10 to the negative 13 joules. That's what it looks like. I don't even know if you can actually see that. It kind of shows up on this. So if we plug that in, again, to our calculator. Calculators are kind of amazing. Times 10 to the 19th, 1.6. Times 10 to the negative 19th, and then 9.0 times 10 to the 9th, all over 9.09 times 10 to the negative 13th. That gives us a whopping distance of very tiny, 2.33 times 10 to the negative 14th meters. It's getting dark. So, yeah, that's our distance, and I'm really hoping that's right. I'm going to check this after. D says this: after the proton has moved away, that uranium nucleus spontaneously fissions into 184.57 La, which is actually Latium? Yeah, I think it's Latium. And 84.35 Br, which is boron? Bromium? Yeah, bromium. Along with 3 neutrons. As a result, 2.5 times 10 to the negative 11th joules of energy is released. Indicate whether the mass of the 23592U nucleus is greater or less than the mass of the fission products. And then it also says calculate the mass difference. You check either greater than or less than. So the only thing that I can think of to do here is Einstein E equals mc squared. So yeah. So delta E equals delta M c squared, because it's talking about mass difference, and that is the difference in mass. Imagine that. So for if you solve for M, you just put delta E on top and then c squared on bottom. And so you put the change in energy, which is 2.5, it gives you that. 2.5 times 10 to the negative 11 joules on top, and then the speed of light squared on bottom, which is, isn't it like 3 times 10 to the something? Yeah, 3.00 times 10 to the 8th meters per second. Holy crap, I have the headache ever. Plug that in. 2.5 times 10 to the negative 11th over 3.00 times 10. I can't even read my freaking handwriting. Times 10 to the 8th? Yeah. Times 10 to the 8th. That gives you. No, hold on. I typed that in wrong. Yeah. Hang on. Sorry, my mom's texting me. No, Roy Halladay tore his rotator cuff. Poor guy. Oh, hold on. What was I doing? Okay. So the speed of light, 3 point, da-da-da. Yep, that's what I did wrong. There was no way it could be that big. I didn't square it. The speed of light. Big deal. I still put the square on the inside of the parentheses. I'm having problems tonight. There we go. So that equals 2.78, because it's 7 times 10 to the negative 28th. It's the change in mass, and so that's kilograms, which is greater than 2.5. Wait, hold on. No. Less than. Hang on. Gotta think this one through. If energy is released, indicate whether. Well, I know that's the mass difference, but I don't know if it's greater than or less than. Okay, gonna have to guess on this one. Hang on. 235 minus 148 plus 84. Okay, there's 3 on the top, and then 92 minus 57 plus 35, and 0 on the bottom. Mass of the is greater than or less than the mass of the fission. Okay, so this is what the mass of the fission left with. There's 3 on top, but it also says along with 3 neutrons, so that would bring that down to 0. And so you're basically comparing our answer with the previous answer. And because this one's 10 to the negative 28th and that one's 10 to the negative 11th, I'm going to say that what it started with was greater than the mass of the fission products. Yeah, just because 2.5 times 10 to the negative 11th is greater than 2.78 times 10 to the negative 28th. Oh gosh, I hope that's right. Man, I got it really dark. So that's my final answer. Hope you like it, Dr. Steen. Hope you're feeling better too. Yeah, I prayed for you. So, there's more to part A. We go down the list. You get to part B. So on, C, D. Yeah. So fun stuff. That was greater than 2. I still have 12 hours to do this weekend. Woo! Whole thing in Latin. Thanks for listening to my pointless ranting. Bye.